Hello, dear Walter. I hope everything is going fine with you. I uh, I read email a couple of times. There is a couple of questions I have. For example, what do you mean by lattice variations? But in any case, I thought maybe creating a basic tutorial for you can be a good starting point for us. Therefore, I am in this video, I'm creating some things, hopefully useful for you, from scratch. So the thing is, I don't know if it's too basic, if it's too slow, you may want to fast forward a bit. But in any case, I'm trying to start everything from scratch. Unfortunately, I can't go into detail of what exactly each component does, especially the ones that are of native Grasshopper components. But the ones that are part of Parakeet, I'll try to explain them. So in one of your emails, you had a couple of pictures. I'll try to replicate those. So let's start everything from scratch. This is Rhino. And I type grasshopper or click on this button so that I can have grasshopper here. So the first step to create something with Parakeet is um, deciding on your underlying grid or tiling. Okay, let me try to draw something for you here. For example, this picture that you sent me, this probably the underlying grid here is a hexagon or maybe an octagon here with something in between. And again, another of that, for example, a cell with something in between, okay? The other one, for example, this one is almost definitely based on a hexagonal grid. Okay, you see what I'm doing? What I'm trying to say is the first decision that you have to make is what is the underlying grid, or we usually refer to it as tiling. What is the tiling beneath that pattern? Okay, so uh, and in the email, you mentioned that one of the parameters you wish to control is how to control the size of the overall pattern or the grid. I'm trying to find your email here. Okay. Generate cool lattice variations. So let's start by that. You can easily go over Parakeet and select any of the tilings you can see here. Okay. Any of them can be foundation for our patterns. Let's start with something, I don't know, something randomly here. All of the components in here have similar inputs. Those inputs are first the plane you wish to generate your plane on, and that is the plane, for example, when we say XY plane, it means that we are drawing on the ground, okay? If you want to create another plane, for example, you see this now is a different plane and now we are working on it. But for sake of simplicity, it's best to keep everything on the ground for now. This size is the size parameter of usually the edges. For example, this, if I input 2, it means that each of these edges are now 2 units. So, for example, 2 centimeters, 2 millimeters, or whatever your unit scale is. So, one way to control the overall size of the pattern is by modifying this. And extent in X direction and extent in Y direction means how many cells you want in X direction and how many cells you want in Y direction, right? 2 cells in X, 2 cells in Y, 3 cells in X, 3 cells in Y. But depends on the propagation method of every cell. You may not get, for example, the exact same number, but it closely uh, resembles this same thing. So 3, 3, 4, 4. Okay. And then if you wish to see the overall dimensions of the whole thing, what I can do is I can get a bounding box. I need to right click union box, and this is a box. I can turn off the preview for this. I push the middle mouse button and disable the preview for this. I can explode this to have access to the edges of it. Here we have error. We need to pass it through a rectangle component. And then if you wish to see the dimensions, I can go to display. Here should be something like a line dimension. Yeah, okay. This is the line and also this other one. So, and for the size, I can input number. Okay, so this is the overall things. Obviously, when I go back and change the dimensions, this can be one way to control the overall dimensions or see or monitor the overall dimensions. Okay, let me turn off preview for everything for now. So the second thing you need to decide is what algorithm should be implemented on every cell. For that, again, we go to Parakeet here, and you can, at least one way, the simplest way is choose whatever you wish from these pattern generation category. A good guide can be look at the icons. We try to design this icon as clear as possible. So for example, when working with this means that it will try to create a shape like this on every cell. That means if we give it a quad face or any different geometry, it will try to draw a line of each vertices and then try to create this shape in between. Same principle can be applied in here. Same principle will be applied on a triangle. So this is only a language, a preview of what will happen inside each cell. Okay? So let's start with something like this. All you have to do is connect the cells to this. Okay. Now we have our shape. Obviously, almost all of them have a couple of numerical inputs that you can decide on the behavior of this thing that happens here. For example, and usually the numbers are remapped between 0 and 1. So all you have to do in simple terms is connect a number between 0 and 1 to see the variations. Also, you may want to not look at the basic tiling and only work with the what we call here genotypes. You can only look at the genotypes, or you can also have the basic tiling as well. Okay, so this is the first thing we can do with Parakeet. Now we can build on top of it. So first thing, look, this was the first element that we decided. This is the second element. The first element was from the tiling section. The second element is from the pattern generation section, right? So we can now change everything. For example, I don't like this this tiling. I can replace it with another one. All I have to do is to change the wiring and get rid of this. Now you can see that I can have the same principle applied on a different grid, right? Um, Let me just for sake of preview add another color for these components that this particular component is from another plugin called Human. You don't have to download it. It's just I'm just using it for the coloring of these things. So let's see this with one color and another color for the pattern. And let me increase the line weight. Okay. So first thing, you can substitute this with any of the tiling you wish. For example, these pentagonal tiling are something that I realized designers they really like these. I don't know why, but um, these are tilings that each cell has 5 edges, and their propagation is a bit the logic that they expand necessitates these movements and rotation, but many instances are beautiful in between, so you may want to use this so simply you can have the logic applied on these two. Anyway, so the first thing is you can change the tiling. Second thing is we can change the pattern generation method. Let's change it with another component. Let me just adjust the number of cells a bit. Okay, instead of this, we can use this one. As you can see, there are several methods. You don't have to create only geometric straight lines with Parakeet. You can create curvy geometries with Parakeet as well. So what are the parameters that we can change here? Degree is, for example, bulge factor is one thing. Anyway, let's try one last thing. For example, this one. Yeah, this can be a cool one too. The ones that have randomness to them, they have this seed input. This should be seed. Oh no, this is the starting index blend. Okay. So this means that this leaf thing, this particular thing, is now starting from the first edge, right? So this is not really a beautiful thing. What we can do here is we can select another one here is called, there should be a component called, sorry, I forgot all the names that I put, random seed or something like that. Yeah, random seed. This component changes randomly where each cell starts. So if we pass it through here, you can see as we randomly are rotating every cell in itself, and now the resulting grid is more stochastic. Anyway, I didn't want to use this one. This is getting more complex. Anyway, let's replace it with another one, and let's try to add more complexity. Okay, um, the first thing is what I can understand from the examples that you sent is I believe mainly you like the traditional patterns. In the terminology of the Parakeet, they are called star patterns. These are usually what you see in some of the uh, ornaments. So I would recommend looking at star patterns as well. For example, this is, I believe, something that was in one of your images. Of course, obviously, the whole purpose of recreating these things algorithmically is to is to explore design space, to play with the parameters and see other possible variations. Um, Actually, I think this was one of the things you sent me. I hope this is at least close. Um, so anyway, you select something from here and you start connecting sliders and play with the parameters, okay? So let me address a couple of other issues you mentioned. How to adjust the size, how to adjust offset on both sides of the center line. Okay, so for working with the adjustment, unfortunately, the offset method that comes with the grasshopper is not very good. Let us try it, but almost every time it fails. This offset curve is grasshopper's native component. Let's try to make an offset with this. This d is the distance of the offset. Okay. You see, the problem is sometimes it offsets in one direction, sometimes it offsets in another direction. Let me, yeah, like I said, it's not working as intended. That is why I never use the offset method of the grasshopper. There's a plugin called Clipper Tools, which has a component called polyline offset or offset polyline. This is the only plugin that I recommend installing. Of course, they are all free, along with Parakeet, because if you wish to manufacture those, you probably need a clean offset, and this plugin uses a library that does this in a great way. So, polyline offset. This is the component I'm talking about. It's from this plugin, the only thing that you need along with Parakeet. So by connecting this and providing a distance, now we can see a really nice, it's best to flatten the output. Yeah, now we can see a perfect offset. Of course, this 14 is this width, is this dimension. Okay. And there are a couple of parameters you can control to control what happens in here. So just input 2 to all these last ones, 1, 0. You can have a smooth connection, or you can have the jagged one. Okay, so this is a perfectly nice. Let me create a copy of this. Offset. So I hope this can address the thing you mentioned about the offset. So the other thing is add a color fill hatch. Uh, well, that's a bit tricky. So my first suggestion is don't do this inside Grasshopper. It requires a fairly advanced knowledge of Grasshopper. I'm going to do it anyway here, but what I would suggest is at this point, when you get your basic geometry ready, just right click on it and bake everything so it becomes an object of Rhino. And then, oops, and then export your baked geometry, export your final geometry to any modeling software that you are comfortable with. For example, I can select everything, go to File, Export. Yeah, export with origin is fine, or export selected. And you can use all these methods. For example, you can use DXF or DWG if you want to export it to AutoCAD. You can use AI to get it into Illustrator, or OBJ is also a simple format. If you create a 3D file, you can save it as STL to feed it into your 3D printer. Almost every Rhino works with almost all of the file extensions. So you can export it here and then work with it in any software that you are comfortable with. But in any case, I'll try to create something here. Let me just try to work with a smaller thing, delete everything. So let's say that this is something that I have, and I wish to have access to all these separate surfaces or regions in between. So the thing is, normally Parakeet outputs everything as curves. So you don't have curves arranged in a format that they can easily be identified as a surface. They are all in an unsorted format, meaning that what we have here is just a lot of curves. Linear curve, linear curve, linear curve. These are all separate curves. So it's almost impossible for Grasshopper to identify which cells form a closed region. There can be a solution if you go to Parakeet and look at here. There should be a component called region. Yeah, network regions. This component tries to find closed regions from a list of curves. There's no guarantee that it always works, but most of the time it works. Yeah, hopefully now we can connect it to, for example, if we want to convert it to surface, we can connect it to boundary surfaces. Yeah, and as you can see now they are, this is the first, second, third. Yeah, now we have access to all these surfaces. So let's try to assign colors. You mentioned add color fill hatch. Let me try to assign colors to it. If it's just for sake of preview, you can use this custom preview component, connect everything, and then using a color swatch, you can assign multiple colors for them. And then when you bake these things, you can assign also material for every layer using this rendering tab and this layers that we have. They all have material properties and everything, right? But like I said, I usually use Grasshopper to generate the basic geometry and then move it to another software. So, just for sake of exploring the possibilities, let me create something here. Let us assign different colors for every face. Um, so what I need to do is here I have 79 surfaces, so I need 79 colors, right? So one way to create a lot of colors is using also a component that Parakeet should have, yeah, interpolate colors. Okay, how this component works is you should give it two or more colors. For example, I want my gradient to start from red and then go to blue and then go to green. I don't know, maybe something like that. I connect everything to C. And then for T, we need numbers between 0 and 1. And the total number of numbers, the quantity of numbers should be equal to the number to the entities that we want to assign color to. For example, if I need two colors, I need to give it two numbers. It uses this number to find a color for everything. For example, this, now what we have done here will say, okay, 0 is my red, 0.5 is my blue, and 1 is my 1 will be green, right? So if I input, for example, 0.65, it will retrieve a color between blue and green, blue and green. If I input, for example, 0.1, it will give me a color between red and blue, which is more inclined towards the yellow. So I know it is getting a bit complicated, but don't worry. So I need 79, right? So there's a component called list length, which will give me the number 79 here. There's only one small catch here. Range by definition outputs one more number. So although I input 79, it is giving me 80 numbers. So I need to subtract 1 from this. So that now I have exactly 79 colors for 79 geometries that I have and I wish to assign color to. Okay, so this can be one method of assigning colors for them. Obviously, you can, if the software you're using is vector-based, which I assume it should be, you can bake everything and use print component from the Rhino and get a PDF version. Sometimes some of these softwares also accept the PDF version. So, and this was for coloring. There's also another thing that I wish you to know is basically, like I said, I assume that these three methods for creating star patterns is more close to what you have in mind. Start size. Anyway, but I guess the Parakeets, one of the advantages of Parakeet can be creating heterogeneous patterns where the behavior is different on every cell. I'm going to create simple heterogeneous patterns for you. Let me replace that with a simpler pattern generation method, genotype. I don't know, for example, this one. Okay, obviously the thing is, we are putting one number for all of the cells. So, for example, if this parameter is 0, that means that this algorithm with the parameter of 0 is going to be applied on all the cells. Okay, if we input 1, that means that that the same behavior is happening inside every cell. So, if we can manage to give every cell a different number, it will create a heterogeneous pattern. How we can give every cell a different number. So one way to do it, I'm going to create a simple version. Let's try to use x value as this parameter. That means eventually I can see a gradual change within that resulting pattern from left to right. Okay, let's try to create those. I'm going to need the center line of each cell. I can use a polygon center component to find the center points of every cell. Then I'm going to need the x value of every point. So I can use a deconstruct component because these are the points and every point has x, y, z, right? Now I'm going to need the x value. As you can see, now I have a different number for every cell, right? Because every cell's center point is at different location, therefore its x value is different, right? So if I use this, it will not look pretty now, but we're going to change it. As you can see, something different is happening in every cell, but it's not looking good, right? That is because the x values are not in the desired range. To change that, we can have two things. First, we can multiply them by a really small number because I assume the numbers are too high for this genotype. As you can see, if I make numbers really small, you can see this gradual change. But the correct way to do it is not by multiplying it. Is to use a component called remap, which is basically a mathematical function. Um, so that means I'm telling this component to look at my x values. This bound component returns the bounds of all my x values. That means it reports that your x values are between -1 to 38. And then I can say, using a construct domain, I can say, okay, I want my numbers to go from a really small number to something like this. Now it is changing my x numbers, keeping their ratio, keeping their relative distance, but it is making everything smaller. It's like having a rubber band and marking some parts on it, and then stretching that rubber band or making it smaller. So all these marks will be moved accordingly, right? Now you can see I can have control over the behavior of the pattern. I can see a gradual change in this direction, no matter how many cells I have. Let us replace it with something else. Like this. So let us see, create individual part drawings and generate 3D renderings. Let's put 3D renderings aside for now. I'm going to need your feedback on this tutorial to see if you're on the same page, if this is what you meant. I'll talk about 3D versions after I send you this. Create individual part drawings. Look, basically you already have access to all of these shapes individually. The thing is, like I said, usually what Parakeet outputs, the result, the final geometry, is a list of curves. They are not arranged in a way that they create closed spaces, right? One way to fix this was using that region component. But technically, this region component may fail sometimes. For some reasons that I don't wish you, I don't want to bother you for now. But basically, if that component works, the resulting thing, yeah, perfect. The resulting curves are the individual parts you referred. Let me try to show some of them to you by using a list item. These are all the parts individually that creates the whole thing, right? And even if you bake this, you already have access to everything in Rhino. This group, this is grouped, I need to ungroup it. See, this is one shape, this is the other one, this is the other one, right? So I tried to, I know it was really all over the place. I introduced a lot of topics and probably um, it's not very useful for you, but I just tried to show what Parakeet does. Obviously, there are a lot of other things that you can do. For example, one of the things I really like is we have two methods that can be applied on this tiling before we give it to the genotype. And that is, there are two components called one mirrored subdivide quad, and the other one is dual graph. So, see, this is the tiling before, for example, passing it through the dual graph, and this is the dual graph. So, before I was generating the pattern on the tiling itself, I can generate it on the dual graph too. It's not looking pretty, but it's something. In this particular case. And there's another thing called mirrored subdivide quad. This is actually, again, can be seen in a lot of ornaments, which looks something like this. Let me show you in a more clear example. Without using the mirrored subdivide quad, the pattern is looking like this. But after using this, it will look like this. Oh, there's something wrong here. Let me fix that. Yeah. As you can see, there is a mirroring quality happening in every cell. This is actually pretty common in some of the masks and tiling and everything. Okay. Anyway, I don't know if it's useful or not, but I thought maybe it can be a starting point for our discussion. And don't worry about paying me or sending gifts or anything. You don't have to do any of those things. I just need to, I'm just happy to help. But unfortunately, I'm studying as well, so uh, please accept my apologies if I'm replying with a delay. So I hope this was useful, and I wish you all the best.